Okay, so we're just more of the same today, just different kind of presentation of instructions. The first one has 4 parts. This A, B, C, and D are 4 different parts to find the absolute extrema of the function, if any exists, over each interval. So really the differences between these intervals are just what's bracketed, what's not, what's included with the brackets or not with the parentheses. So on the interval from 1 to 4, I'll just find all of the points. So 1 comma, 4 comma are our endpoints. And so the one endpoint is at 1, 4. The other one's at 4, 1. If I want to find my other critical points, I take the derivative, f prime of x, which is just -1, and set it equal to 0 or equal to undefined, and find out where it would ever equal 0, where it would ever equal undefined, which is kind of silly to even think about here because this is a line, right? So that will never equal 0, that will never be undefined. So the only critical points we have are 1, 4, and 4, 1. Now, depending on which part we're talking about, we are including both endpoints, including only one of the endpoints. So in part A, this would be the line graph with 2 solid endpoints. So we do have an absolute max. So if I just do this quickly too, 1, 2, 3, 4, 5, we're really looking at this. And in part A, those are filled in. So the absolute max, why am I at 0, 5? The absolute max is at 1, 4. And the min is at 4, 1. On part B, if this was a solid circle and this now was an open circle, our absolute max is still 1, 4, but the absolute min does not exist. It's getting infinitely close to 4, 1, but it's never actually going to touch it, and you couldn't just define the lowest point it ever gets to. In C, the absolute max does not exist because this would be an open circle. In a closed, I think we get the point, and the minimum would be 4, 1. And this one, neither exists. We have no, if they're both open circles, we don't have an absolute max, we don't have an absolute min. Okie doke. On this next one, we've got some different endpoints on each section. So I'll start with part A. So we've got -2, comma something, and 2 something. They're both 0 when you plug them in. And then I'll take the derivative. Oops. I'm rewriting the original as 4 minus x squared to the 1/2 power. So a power rule followed by a chain multiplying by the derivative of what's inside. Your 2's will cancel. Oops, I forgot to drop my exponent. So 1/2, 4 minus x squared to the -1/2 times the derivative of what's inside. And then I'm going to clean this up just by moving this to the denominator. So I'm going to have -x over root 4 minus x squared. So when will this equal 0? 0. So critical point is at 0 comma, plug that in, 2. And when will it be undefined? 2 or -2, and we've already covered those. That's when our denominator is 0. Where else is it undefined? At 2 and -2, because that'll make my denominator 0, but what about the radical? Right, anytime we get a negative under a radical, which is going to be anytime x is greater than 2, like 4 minus 3 squared would be a problem, or less than -2, which we don't really have to worry about here because that's out of the interval for all of these. So this graph actually only exists between -2 and 2. Okay? You can see that up in the original as well. So if we're including all endpoints, we have a max at 0, 2. And we have 2 minimums, -2, 0, and 2, 0. So for part B, when our interval is just from -2 to 0, we can't involve this second point at all. So the minimum would be this point, which is fine because we're including that endpoint. So the minimum is -2, 0. The maximum would have been this point, 0, 2, except for we're not including that because of the parentheses. So the maximum does not exist. Just a lot of little finicky things here. Nothing overly huge conceptually, but keeping track of what's included and what's not. From -2 to 2, both with parentheses, the only point we have as an option is this 0, 2, because these are both not including the endpoints. So we only have a maximum here at 0, 2. And then for D, kind of shifts it up a little bit for us, it's changing our endpoints from 1 to 2. So we need to check 1 as an endpoint now. So if you plug in 1, 4 minus 1 is 3, you get √3. So you're only really looking at this point and this point for part D, from 1 to 2. The maximum is this one, which is included because we've got a bracket around the 1, so we've got a max at 1√3. Our minimum would have been at this point 2, 0, but 2 is not included because of the parentheses, so minimum does not exist. Just tedious, really, nothing overly crazy. In the next section with the piecewise function in step 1, it tells you to sketch the graph of the function, then locate the absolute extrema. So we have a parabola that has endpoints at 1 and 3, and then it transitions to a line from 3 to 5. So I think the best way to do this is come up with your endpoints of the parabola. So 1 comma what? 1, 1. Close circle. This is, well, and then an endpoint at 3 comma what? -7, 2, 3. 3, -7, and that one will be open. And this parabola opens downward, yes? It's a parent graph that's been flipped upside down and shifted up 2. So this kind of has to have the bend like that, if you want to label the points for ease of remembering. Our line starts at 3, and then 2 minus 3 times 3. 2 minus 9 is -7. So our line actually starts there. So it's going to fill in that circle and ends at 5. 2 minus 15 is -13. I'm just going to do that. I plugged in 5. So we have a continuous function and locate the absolute extrema. So the absolute extrema max would be 1, 1, min 5, -13.
Pardon the interruption. We're going to do a shelter in place at this time. Once again, we're going into a shelter in place at this time. Thank you.
Where you had a date? All right. Any questions on that? Feels very similar to like limits, like in the fact that sometimes you're going to have to pull from your knowledge of the graphs and from calculations and so forth. Not this one, you don't. This one would be a little bit tricky because you'd be taking the derivative. There actually is no place where that's going to be 0 undefined on this interval. It's very choppy. We could do it and kind of show how it would work. We would get, this derivative equals 0 at 0, but again, it's out of intervals, so you'd have to not pay attention to it and so on. Sometimes just knowing what these graphs look like and dealing with a line especially, you just kind of save yourself that time. The next one is a rational function. Where is my asymptote? 2. How about a horizontal asymptote?
0.
Small over big. It's at 0, correct? See, we're reviewing for the final. And they only want to see this from 0 to 2. So if I plug in 0, what's my point?
1.
Right? 0, 1. And so it kind of tells you that this is going like that. You can just double check. If you plug in 1, you're going to get 2. So it's definitely going upward. And our interval includes 0, so it's an open circle. It doesn't include 2, not because it's an open circle, but because we know there's an asymptote there. So the absolute min is 0, 1. The max does not exist. The section at the bottom wants us to graph a function based on certain characteristics. So first and foremost, we're only dealing with the interval from -2 to 5. Brackets, so we're going to have points. A relative minimum at x equals -1. So I'm just going to, it doesn't have to be down necessarily, but I'm going to do something like that at -1. Just so I know it's reaching a minimum of some sort and turning around. Critical numbers at x equals 0. So there's a critical number at 0, but it's not an extrema, so it's not going to be a max or a min of any sort. So there's only a couple things that could happen there. If it's a critical point, it has to have a slope of 0 or undefined, but yet it's not going to be a relative max or min. So I'm just going to kind of do something like that where it flattens and then carries on. Right at an x coordinate of 0. There's an absolute max at x equals 2, so maybe I'll let it get up to there. And an absolute minimum at x equals 5. So I want to make sure that at 5 it goes lower than that relative minimum. And then whatever happens thereafter can happen. I just have to make sure that whatever I do to get over to -2 doesn't go higher than this one, because that still needs to be an absolute max. So you can just do that, whatever you want to do. Lots of different ways those can be drawn. When that's a problem, I'll just go through the checklist and make sure all of those things. Relative min at -1, got it. Critical number at 0, but not an extrema, got it. Absolute max at 2, you just want to label this. And an absolute min at 5, so I don't know. 1, 2, 3, 4. Any questions? True or false? If a function is continuous on a closed interval, then it must have a minimum on the interval. Digest that. Try to think of a counter example. If ever you are leaning towards true, try to think of a counter example. Or sometimes if you know it's false, just have a counterexample prepared. Okay. Are you ready to vote? I'm going to have you hold up 1 for true or 2 for false on the count of 3. 1, 2, 3. Ooh, good little debate here. I think it's about half and half. So the true people I'm not going to start with because they obviously couldn't think of a counterexample. But Lily, can you share with us what your counterexample was? Something that...
It's like y equals a number and 3 or something, and then over a closed interval.
Okay, so
Would be a minimum.
1, 2, 3. So if you have like a flat line like this over a closed interval, raise your hand if you thought of that and still answered true. Oh, okay. Raise your hand if you have a different counterexample. Those false people. You said true.
No, I didn't.
Oh, you said false? What was your counterexample?
Well, I could have thought of is it saying absolute minimum or just a minimum? Is that what we're referring to?
It could be a maximum or a minimum, or a relative or an absolute.
Oh, then I was thinking of it. 'Cause I was thinking of absolute minimum, so I was thinking like a sine graph. How there's no true absolute minimum, which is it's not an absolute minimum; it's a relative minimum, isn't it?
It's both.
Yeah, I thought relative minimum means you multiple absolute minimum, so the lowest point of the graph.
The absolute minimum is the absolute lowest y value that ever gets reached.
Then what's the difference between that? What's a relative minimum?
So, all right, let's go back and review that. Let me start. Go back to. Let me answer this one, then we'll go to Stephen's question. And what I'm saying is going to help you because this is a great thought, but I think the debate still would be out there. The absolute minimum of a graph is the lowest value it reaches. So, what's the absolute minimum of this graph? 3. It's obviously a quirky case, but this is a great counterexample thought, but leads to this discussion. This still has a minimum. This has a minimum value of 3. Weird because it's infinitely 3. Weird because the maximum is also 3. And so it's definitely an odd example worth, talking about, but this does have a minimum. Jalen.
Isn't it true that like anything has to have some lowest point? Like something will always be the lowest?
No, not open intervals. And that's because of the idea of infinity, though. So if I do this, that doesn't, even if this is at -5, let's say, that does not have an absolute minimum. Because there is no absolute lowest value that it reaches because it's getting kind of infinitely small, which is, again, the weird infinity concept, but the fact that numbers can do that. But that would be one that it doesn't. So back to Stephen's point about a sine graph, the minimum is the absolute minimum, and these are all relative minimums as well. What was your question? It made me think of a whole different thing, but...
Like, I always thought, I feel like I remember someone telling me that an absolute minimum is the absolute lowest point. And no point is lower than that, but a relative minimum, you could have multiple of them.
Right. Now, if I did this, now this wouldn't be a sine graph, but these would be absolute minimums. If they're, obviously, we'll just assume they're even with each other. These are the absolute minimums. They're also relative minimums. These are relative minimums, but not absolute.
You can have multiple of both.
You can have multiple of both, yes. Definitely. And also the phrasing, like what is the minimum value? You would just be looking for the y coordinate. If they say what is the where are the absolute minimum points, and I think that's the point of confusion, is that yes, you can have multiple absolute minimum points. Does that clear things up? Any other questions on that? Okay. Second, true, false. So this one was true. If it's closed, it must have a minimum. If it was open, to Jalen's point, not necessarily, wouldn't. All right, number 2. Read, think, and then we'll vote. One is true, 2 is false. Ready, set, vote. Oh boy. 3 is abstain. Who voted? I missed. Oh, you said raise your number so I know. 3 to 2. What did you vote, Josh?
True.
And I want to talk to the false people, so like a Taylor, go ahead.
So, say x equals c was like x equals 5. If you're shifting the function over horizontally, then it wouldn't be at the same x value.
She's correct. So this is false because, and I kind of added a number in here so we could see it. This one has a critical point of 4. So let's pretend this is our f of x. If we then do f of x minus 1 and shift this to the right 1, that's no longer going to be a critical point at 4 anymore.
I thought that was asking that not the number of that, not x equals 4, just that they're still going to be the same critical value is what I thought it was. Never mind.
You interpreted it
Yeah,
incorrectly.
it's a different x that they're still going to be done.
Okay, you follow what it's saying now?
Yeah.
Okay. So just because once it's a critical number in one function, if you shift it left or right, it's not going to be a critical value anymore. If you shifted it up or down, like if this had been f of x plus k, that would have been true, right? That make sense? If you shift things up or down, if this has a critical point at 4 and you move it up or down, it's still going to have a critical point at 4. What about a stretch or compression? What'd you say, Stephen?
I'd say it wouldn't matter.
Well, your answer should more be like, it depends. Because a horizontal stretch or compression is going to change the location. So pretty much anything horizontal is going to change the location of the critical point. Unless it was at 0. And then it might not, stretch or compression. But vertical things will not. Stretches and compressions will not. Any follow-up thoughts, opinions? Liam, I'm sorry. I miss you over there.
You didn't miss me?
I miss your hand.
Yeah.
I don't see you. I mean, I'm sorry that I didn't call on you more because I know you